Hello friends, welcome to Physics by GD. So today we are going to solve the exercise number 11.5 from the chapter number 11 Fourier Series from the book Mathematical Physics by H.K.Dass. So this exercise has only one question and it is based on Parseval's formula. So the first thing is, what is Parseval's formula? So Parseval's formula is 1 upon c integration minus c to plus c f of x mod square dx is equals to a naught square by 2 plus summation n starts from 1 goes to infinity an square plus bn square. So this thing is called as Parseval's formula. So with the help of this formula, we can find the value of series from this formula. Okay, so this is our question. Question number 1. Prove that in 0 to c interval, function x is equal to c by 2 minus 4c upon pi square and this thing. And deduce that first 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4 up to infinity, where it is odd term, is equal to pi raised to 4 upon 96. And second thing is, here we have included everything, odd and even both is equals to pi square upon 90. So we have to show this. Okay, first we have to show this x is equal to this thing, and after that we have to deduce this series value, which is equals to pi raised to 4 upon 96 and pi square upon 90. So here it is pi raised to 4, one correction is there. Okay, so our given function is f of x is equals to x in the interval 0 to c. So here we will find the Fourier half range cosine series. Okay, so as you can see, this contains only cosine term, so I am calculating here Fourier half range cosine series. So first I will calculate a naught. So a naught is 2 upon c 0 to c f of x dx. So since we know that 2 is multiplied for half range series, right? So 2 upon c 0 to c f of x dx. So it will become 2 upon c 0 to c function is x. Okay, so x dx. So this will give me ultimately a naught equal to c. Now I will calculate the Fourier coefficient an. So an is equals to 2 upon c 0 to c f of x cos n pi x by c dx. Okay, so the function is x. I have substituted here. So integration of x into cos n pi x by c is nothing but x into integration of cos n pi x by c, which is sin n pi x by c divided by n pi by c. Okay, minus integration of derivative of x, which is 1, and again integration of cos, which is sine. So again integration of sine will give me minus cos, so it will become plus cos n pi x by c divided by n pi by c whole square. Okay, so we will put the limit 0 to c, so it will, this term will be 0, because if we substitute c, so it will give me n pi c by c, which is nothing but n pi. So sin n pi is always 0, and again for 0 sine will give 0. Okay, so this term is equal to 0 plus cos n pi x by c, so it will give me cos n pi, which is minus 1 to the power n, and cos 0 will give me 1. So I am getting 2 upon c into c square n square upon pi square minus 1 to the power n minus 1. So this is nothing but an is equals to 2c upon n pi whole square minus 1 to the power n minus 1. So for n equal to even even value, it will give me plus 1, and 1 minus 1 is nothing but 0. So ultimately for even value of an comes out to be 0. Okay, an comes out to be 0, and for odd value this will give me minus 2. So value of an comes out to be minus 4c upon n square pi square. So our function becomes x equal to a naught by 2, which is c by 2, plus summation n starts from 1 goes to infinity an cos n pi x by c. So the value of an is minus c minus 4c upon pi square n square. So I am taking minus 4c upon pi square common here, as you can see, and summation cos n pi x by c upon n square. So x is equals to c by 2 minus 4c upon pi square bracket For n equal to 1, it will give me 1 upon 1 square cos pi x by c, and for n equal to 3, it will give me 1 upon 3 square cos 3 pi x by c, and up to infinity. Okay, so the first thing we have shown this, which we have to prove, we have proved this thing. Okay, so now we will deduce these relations. So this is the important thing where we are going to use the Parseval's formula. So according to Parseval's formula, so the Parseval's formula is 1 upon c minus c to c f of x mod square dx is equal to this thing. So here we have calculated the half range cosine series. So Bn is 0. Okay, so Bn is 0, and since this is half range series, so here 2 will be multiplied. As we know that for half range series we have to multiply by 2. Okay, so the formula becomes 2 upon c 0 to c f of x mod square dx is equals to a naught square by 2 plus summation n starts from 1 goes to infinity a n square. Okay, so 2 upon c 0 to c, function is x, so x square dx equals to c square upon 2 plus, here it is, minus 4c n square pi square whole square. So this will give me 2 upon c cube by 3, because integration of x square is x cube by 3. So c cube by 3 is equals to c square by 2 plus, because in square of 4 is 16, and c square pi raised to 4 summation n equal to odd value 1 upon n to the power 4. Okay, so it will give me, so I am cancelling c square here, so c and c cube will give me c square, and c square I am taking common everywhere and cancelling c square. Okay, so I will get 2 by 3 and minus 1 by 2 equals to 16 upon pi raised to 4, and this thing. So it will become 1 upon 6, 2 into 2 is 4, and minus 3 is 1 by 6, so equals to 16 upon pi raised to 4 summation odd 1 upon n raised to 4. So summation for odd value 1 upon n to the power 4 is nothing but I am multiplying pi raised to 4 here and 16 and dividing 16 here. So 16 6 time is 96. So summation of odd is nothing but 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4 up to infinity. This is equals to pi raised to 4 upon 96, which we have to deduce. So we have did this. Okay. So now we will calculate the second part. So for calculating second part, I have calculated half range sine series, but this will not be needed here. Okay, so for deducing the second relation, first let us consider summation n starts from 1 to infinity is 1 upon n to the power 4 is equals to summation odd value 1 upon n to the power 4 plus summation n value 1 upon n to the power 4. So this means that 1 upon 1 raised to 4 plus 1 upon 2 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 4 raised to 4 up to infinity, I can write this thing as 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4 up to infinity plus 1 upon 2 raised to 4, 4 raised to 4, 4 raised to 4 plus 1 upon 6 raised to 4 up to infinity. So as you can see, I can write this thing as summation n starts from 1 goes to infinity 1 upon n raised to 4. And I can write this thing as summation n having odd values up to infinity 1 upon n to the power 4. Plus I can write this thing as summation n taking even value up to infinity 1 upon n raised to 4. So here this is the thing which we have written here. Okay. So now what I am doing here is that since n is equals to even value, so it will start from 2, then 4, then 6. Okay, so and this thing is starting from n equal to 1, 3 and this types of value. So I want to make this n start from 1. So what I am doing, I am replacing n by 2n. So by doing this thing, so my values of n becomes 1, 2, 3. So if I will change n to 2n, so it will give me this thing, and the value of n now starts from n equal to 1. So this will give me even terms. So put n equal to 1, it will give 2 to power 4. Put n equal to 2, it will give 4 to the power 4. And same thing, both things are same. Now look closely, 1 upon 2 raised to 4. So I am taking 1 upon 16 common here, and I am left with summation n starts from 1 goes to infinity 1 upon n to the power 4. So you can see this thing and this thing is same, which we have to calculate. So I am considering this thing as yes, so it will become yes, 1 upon 16 times s. Okay, so I am taking this thing to the left hand side, it will give me yes into 1 minus 1 upon 16 summation odd value 1 to the power 1 upon n to the power 4. Okay, so this is nothing but we have calculated just now, which is the first relation, odd values is equal to pi raised to 4 upon 96. So this is nothing but pi raised to 4 upon 96. So 16 minus 1 is 15 and upon 16. So 1696, if I cancel out, it will give me 6 times. So yes comes out to be 15 into 6, which is 90. So pi raised to 4 upon 90. So summation n starts from 1 up to infinity. 1 upon n raised to 4 is nothing but pi raised to 4 upon 90. Okay, so this is the relation which we have proved, relation number 2 also. Okay, so this was our exercise number 11.5. so this exercise contains only one question, so that's it for this exercise. So guys, if you find this video helpful, so please like, share and subscribe. Thank you for watching.